Okay, welcome all of you. As I told you in the mail, I forgot to mention about the week reference, which I should not miss it today. Akash, please remind me if you are there. So we will maybe this should be first, then photo session we can have. So as I told you, I would like to have a photo of all other participants in this class so that it will be a good memory for all of us. I will screenshot it and share it with you as a PPT, as a PDF, part of the class. So let us do that at the end of the class. By the time, hopefully, maximum people should be in. So today, what I plan to do is, yesterday I talked about the way text files are saved in Linux and Windows, and I told you also that I will show you a demo of that on a Linux platform. So I thought I will do it today. And then we will see a simple GUI implementation using tkinter. People pronounce it as tkinter or tinker. Okay, I don't know which is right. tkinter is actually very straightforward, so we can use that separate. And then weak reference, I will tell you. SQL database, then weak reference, then we'll have a photo session. Okay, I wanted to do a socket programming also, but looking at the list in a day, if it is more than this, I think there will be a natural saturation for all of us. So let us not have any break. Maybe most probably maybe 1.5 hours or 1 hour 45 minutes we should be done. So instead of wasting time 10 minutes and then catching up, let us go forward. I think it's okay with you. In case if you guys want a break, anytime you can tell me, we can stop when you are transitioning from one topic to the other. Okay. So first thing, text file in Linux. Okay, on Windows. Now text file saves the characters as a bytes, right? And then the encoding could be ASCII or UTF-8. Different editors and the OS platforms follow different encoding schemes. Assuming whatever may be the encoding, it is actually independent of the encoding. When a text file is saved, we have to give a carriage return, which I mentioned that for the starting of next line. And this is in Windows, it is carriage return and line feed. Okay, this is 13 and this is 10. Whereas in Linux or Unix, okay, they follow only one character. It's not both of them. Okay, and Mac is also follows only one character. Okay, I think this is line feed and this is carriage. Okay, whatever. Now, how do we know whether we demonstrate it on a platform, both platform? Okay, so what did I do? I have an installation which is called WSL. I am not sure whether you have heard of it. It was released almost 2 years back. Okay, see, you know that there is a fight going on between Windows and Linux. The fight means Cold War. Most of the people are preferring this, developers, than this, and this is a proprietary and this is open source, which is a very big open source. I'm not talking about OS. So big advantage. Now, what happened after Satya Nadella took over, and he wanted to make friendship with Linux, not as an enemy. Okay, if you cannot beat an enemy, become a friend with them. Okay, then both of them will flourish. I'm not saying that Windows is inferior, but Linux was taking over many of the areas where servers and web servers and many of the things are being run on Linux, and Windows was losing their market space in these areas. And naturally, this Linux supported by open source developers is lots of development happening, lot of features happening, and lot of support for um, different technologies are there, and they are doing a better job in terms of making it free and allowing the open source community to contribute. So what did Windows do? They allowed the Linux, or they supported Linux on Windows. That started from Windows 10. They call it as Windows. Actually, 2016 it started. Okay, not 2 years back. Windows, no, 2016. WSL is Windows Subsystem for Linux. Subsystem for Linux. Now, what is this? WSL is a kind of a virtual machine. Now, all of you might have heard a virtual machine is nothing but a technology wherein you can have multiple different operating systems. Maybe I'll call it as OS1, OS2. Okay, OS2 was itself a operating system, but okay, we can have a Linux Ubuntu running here, or Debian here running here, maybe some other OS running, Mac OS running here, and then we have a hypervisor or some mechanism, okay, which actually allows different operating systems to be run on a base OS. Okay, there is these are all called guest OS. Okay, and then we have a home OS, or base operating system, which is running on the hardware. Now this hypervisor hides which OS is actually which operating system. You may be running a Linux Ubuntu here, you may be running maybe a Debian Linux here, maybe Mac OS here, but finally if it has to run on the hardware which is already booted, okay, this is booted with an operating system called maybe Windows 10. So Windows 10 is running, and Windows 10 controls the hardware. Okay, all the interrupts coming from the hardware, and even any instructions which are being executed on the CPU, everything is basically the operating system APIs. Okay, these APIs are running, and this operating system has the system control. Means there are two modes. You know that user mode and system system mode. Okay, so this controls that operating hardware. So user mode is here. Even this, sometimes even this operating system may be like another application on top of this base OS. Okay, whatever is the OS which is already having a control on the hardware. So this hypervisor hides the information that different OSs are running on this machine. Similarly, even the operating system running here doesn't know that maybe it is OS may be knowing, but applications of, suppose if you are writing an running an application on this OS, it doesn't know that it is running on a virtual machine. That is hidden. Okay, so you get a feel of, or the environment of this operating system, whatever is the operating system you are running, but basically it is running on a platform which is already having another operating system underneath. So how does it happen? It happens because they convert all the OS calls coming from here into the operating system which is owning the hardware, which is running on the system. Then you can easily run anything. Now the problem in this kind of a technology is it is not as fast as you run this particular Debian OS on the hardware itself directly. Okay, if Debian is controlling the hardware directly, suppose if you have a partition, do a boot, dual boot partition, and then you are running that operating system directly on the hardware, it is going to be much faster. Okay, so then what is the advantage of having these virtual machines? Because as a system developer or a product development, you may be releasing some Python code for, as you know that Python is OS agnostic, so you can develop some application on Python and want to release it on a Linux platform or Windows platform as well as Mac platform. But unless you test it out on the relevant operating system, you don't know whether your Python program really runs or not. So we need that. In that case, what we need, you need to have different machines with all the operating system ported. Instead of that, what you can do is have a virtual machine setup, then port particular OS on that, run on it, and then run your Python code on it, and then it runs on the, actually as far as Python is concerned, it is running on the maybe Debian OS or Ubuntu OS, but actually you get a know whether it is running fine or not. Okay, that's the beauty of or advantage of running virtual machine. You don't need to have multiple machines booted with different operating systems where you when you have this kind of a feature. Now, once you know what is virtual machine, then what is WSL? Now, WSL is Windows Subsystem for Linux. Is a direct support of Linux on this. Okay, and especially WSL2 is the latest release, which came in 2019 July or June. Okay, which actually helps you in terms of running any Linux flavors. Okay, any Linux flavor, you can have Ubuntu or any of the Linux flavors. You can run it. The advantage is it is much faster than the normal VMware OS, because VMware is one company which provides you virtual machines, and Oracle also provides you VM virtual machine. Okay, which is also virtual studio or virtual office. Okay, sorry, I have that. Let me check. I forget the name of this. Oracle Virtual Box. Okay, so it is here. Okay, Oracle Virtual Box. So you can have those things. Okay, Virtual Box. Also you can run it, but it is much slower, and you need to reserve some space, memory, RAM memory you have to reserve, and it is much slower than what you see with the WSL. Okay, so what I'm planning to do is today, coming back to a text file, I want to run a Python code, okay, which is running on Windows, and then I want to take it to WSL, okay, platform, which is I installed it. WSL is one package which actually Windows 10 comes with that pre-installed. So you can install Ubuntu or any other OS. You can read about it, and then it is very simple. So what happens is you run a Linux environment on a Windows platform, and you don't need to dual boot or something. You can have it together. Okay, you can have parallelly Linux also running and Windows also running in the same machine. So let me show you that environment. Now I have installed it. So if I say Ubuntu, okay, it says Ubuntu app. Okay, it's like an app. I can open it, and it opens a Linux window. Okay, it's a Linux terminal. Okay, if you want to know what is the Ubuntu running here, so this is what is running in that machine. I have installed Ubuntu. Now this is like a Linux platform. Okay, it's home, it's Mauli, everything is you are like opening a Windows terminal. Only problem here is you cannot open any GUI or anything. Okay, but you can use it as a terminal and do all the Linux based commands and other things you can do. If you want to edit any file, maybe Nano you can use it, which is an editor, text editor. But you can also edit it here on Windows and easily translate it to or send it to the Linux box here. So how do you access this particular directory? Okay, a structure. I have actually created a directory called try, and then I have programs, and I have written C and Python program. So I can I have moved some files here which we wrote it some time back. Okay, for multiprocessing, which we wrote it for our classes. I have moved it here and ran it here. Okay, now file system, I have some files which I want to run it here and show you. So it also, this Ubuntu comes with the Python 3, okay, pre-installed version. So we have a Python 3.8 here running here, and what we have on Windows is I forgot. I think it's up to 3.8. Easy method to 3.88, but that is 3.81 what I have on Linux platform. Okay, so these are the some windows I have opened already. This is the Linux machine. Remember, this is also running on the same laptop. Okay, the machine. Now what I want to do is just want to show you some code. Okay, now I told you that how the text files are different. So let us look at the same text file that we have seen yesterday. So let me open it on this. Okay, I don't want the latest edition. Okay, now make it small. I have how many um, characters? 5 characters in each line, and then there are 4 lines, so 20 characters, and then we have how many carriage returns? Every line is ending with a carriage return. 1, 2, 3, 4. So 4 line divisions are there. In that case, as I told you, Windows is saving it in carriage return. Next line is saving it as CR and LF. So 2 characters. That means 4 into 2, 8. And then 5 characters are there. Line 1, line 2, 3. So these are 5 characters. There are 4 lines. So it is 20. So totally, the number of characters in my text file on Windows will be 28. Okay. So now how do you know that? Okay. Now I am going to run this. Let me show you. I opened the same file which I opened it on my text editor, text1.txt, and then I am seeing the type of this. Okay, that read line. I am reading a line which is line 1. Then I said that file position is 7. Then you know that it is because of 5 characters in line 1 and then 2 characters, so it is 7. Now I have printed the statistics of or information about this file name. Okay, this is a handler. Dot name is the input given to the function os.stat and gives you the complete information about the file. Now if you look at, I am not going to see different things, but except this size. Okay, this size of this file here is 28, which I counted it and told you that it is 28 because of 4 lines are there, carriage returns are there. So you are convinced that in Windows it is like this. Now what did I do? I moved the same file into Linux machine. Okay, what I do, I did 2 things. Okay, there are files here, text1, which is exactly copied from Windows to this machine. Now how do I do it? It is very straightforward. You don't need to actually worry too much. I'll show you just for if you guys are keen to know how I am accessing it. From the Windows machine, you can access it by // WSL $. Then it actually opens up the Ubuntu directory. Okay, so let me show you. Now // WSL $. Then it opens the Ubuntu machine installation that I have. I go there, I get to see the Linux directory here. Okay, it's so easy that even the Windows Explorer you can run through your Linux file system. Home, small, then I have the try procs, which I showed you on the Linux window. I'm showing you the same directory structure on the Explorer. Okay, so now what is the advantage? I can easily drag and drop any files into that direct file, and then I can even take it from here and move it to the Windows platform. So you can exchange the files so easily between the Windows system and the Linux system. Okay, and if you are not very comfortable with any editors there, you can edit it here on Windows and put the file there. That's what I did, because I don't like Nano or any of the editors which doesn't have a GUI. I am very fond of GUI related text editor. So now what did I do? I moved to the same file what I am running here to the Linux platform also, and then I am going to run the same program opening the same file on Linux. Okay, so let us do that. And sorry, let me open the Linux window. Now what I'm going to do, this text file is the same file. Maybe if you want to know, I will tell you. This is the file which is there. Okay, now I am going to run the same code, Python 3 session 17, this. Now what did I do? I am added one more thing here. So let me open that file, what is running here. So instead of opening, I will print it. Okay, I will print this file. Now this is the Python file I am running. Okay, maybe This is the Python file I am running. I hope you can see it. Now, what do? Same file, get cwd, and then text file is the Windows file. What I have saved it on Windows, moved it there and running it on Linux. Okay. So it will keep all the carriage return, line feed, everything, because I have not changed the file or edited the file on Linux platform. So it is as good as what was there in Windows, the same file goes there. So I open it there on Linux platform using Python, and then I print the status. Then what did I do? I saved the same file on a local Linux platform. Okay, I opened it on an editor and saved it on Linux. Okay, the same content I saved it on Linux. That is a local text one. And then I am running that also. I'm opening that file and looking at the content of that. Okay, so I'll tell you more of local. This is the file which is saved, same content from Windows I have taken, and then I opened it and then saved it on Linux. So in Linux will save it on its own platform in the way it saves it, not as a Windows. So if I run the code now, Python 3, if I run the code, I see 28 here, which is the original file I moved from Windows, which is not modified on Linux platform. So you get the size of the file as a 28. Whereas I see the same content, line 1, line 2, line 3. Okay, I will open it on nano local file. See here, it is also having one carriage written here, and then three, totally four are there. Okay, four carriage returns. So this file, when you see the status, it says 24. So what does it mean? That means that you have, for every line there are 5 characters, so there are 4 lines there, but carriage return is only one character is stored in Linux. So you get four of them here, and then 5 into 4, 20 plus 4, so 24 is the size of what you see on Linux. So this is just to convince you, or show you that sizes are different when you see the files on both. So now how does the Linux handle it, or editor handles it? Because they know, okay, some file may be followed by carriage return or line feed. They open it in the same way file saved on a local machine. So even if I open the text file which is saved on Linux with the carriage return and line feed, sorry, Windows, it was saved on Windows, I copied it there. If I open it here, it just opens as way it sees that. Okay, it ignores the double characters coming there. Okay, so I hope this is clear. Any questions or any doubts you can ask me, and then you can see that even the file position, I told you that it will be different. So it is 7 here, whereas file position after reading line 1 on Linux file is 6 here. Okay, I wanted to show you yesterday and I thought I will demonstrate it today. This is very important to know about between two operating systems, how things behave. Okay, any questions on this before we go into the today's agenda? I don't know. I hope you followed what I said. Maybe I was a little faster. Is it okay? Shall we move on? Okay, thank you. So let us go forward. I'm sure you guys want to wind up fast. So let me just quickly go through the Tinker, which many of you maybe are already using it. So if you want to install it, okay, I've given the list of things to do. You have to open Anaconda Navigator console window, okay, and then I think it is pip3. You see Conda list, okay. If you say Conda list, it will list the TK also as a part of the pre-installed packages, but still don't believe it, and I suggest you install it, okay, using the command pip3 install tk. Okay, then you will get the latest version of Tinker being installed on the, if you are using Anaconda, and then you will be able to use the program that I am sharing it to you. Okay, if you, unless you do that, the program that I share will not be running. So Tickle TK was a earlier GUI language which was generic enough. Okay, the people were earlier when I was in 1987 or 1990s. I was developing a graphics code on Visual C++. Then I have to use the Windows platform and Windows APIs for building the GUI. It was very difficult. I have to give the particular, of course, even here you have to give the coordinates of the window and then where to draw the line, where to draw a picture. It was very tedious, and then it is very language and OS specific. And the advantage of TickleTK is that it is like a Python, which is OS agnostic. So you can develop a GUI application on TickleTK, and you can run it on any of the other platforms as far as you have a TickleTK interpreter, like a Python. Okay, it's a cousin or a previous generation interpreter based language development, which was not new to Python. It was there. TickleTK was way in 1980s, I think. They came up, or early 1990s. It was there very much. So what happened is, because TickleTK was there prior to Python, and Python, what did they do? They absorbed all the features of TK and put into this Tinker or tkinter module, which actually underneath it uses the TK module, and we developed GUI using this package. There are many things. I'm sure you may be knowing more than what I know. I thought I'll give you one flavor of this. Okay, I understand that even this is a very most popularly used platform, but I think there may be much better packages available on Python for GUI development. So this is one just an example. Okay, it's a combined TK Tinker provides a fast and easy way to create GUI, and you can create menus and buttons and then responses, all the widgets. Okay, we can get widgets and then create widgets and develop a they're decent GUI app much faster. Okay, compared to what it used to be very difficult in 20 years back. So I just gave a program, and this is like a child drawn some picture. So ignore it. Okay. Before going to database, let us just try to understand this code. Okay. Now, basically, before I go there, I have to give you a little bit of overview what actually it means. Now, our window or screen, okay, whatever the screen of display screen, um, is coordinates are taken like this. Okay, this is x-axis, this is y-axis, and there is no negative. It's not like xy. Okay, it's not a third coordinate. This is 0 1 2 3 4 and 0 1 2 3 4. It is going like this: 1 2 3 and 1 2 3. Okay, this is the corner. Okay, so any pixel here, okay, this is the origin, and then it goes like this. So if you want to draw maybe 100 pixel here and then maybe 10 here, then this you have to give this point is chosen by this uh, coordinate. Okay, x and y. So this top corner, okay, top left corner. Okay, that's the basic thing to understand the rest of the thing. Okay, now we have a class application imported inherited from TK frame. So you have to, our application is restricted to this frame. So very easy to create a GUI application. You have to inherit from here, and then in it you can have some keywords are there, master equal to none. Okay, and then I'm not going into the details of this. You can have whether you want it to be packed or you can expand it or not. Those things are there. Some of the create a widget is I'm creating a widget which is a method here within this class. Okay, and then I put some button. I create a button. This is from the TK. I create a button, and then I write it. Okay, let me run it so that you will have a better idea of the code. Okay, rather than I explaining it. Oh, sorry. So this is going to be a quick demo of GUI. So this is what I am trying to draw. Okay, first initially in this application. So hi there, if you want to know, uh, it will print it. Okay, when I'll tell you, when I print it, press it, it actually it would have come when I created the widget, so it is gone. Now I am printing I'm putting a button, and then hi there is the name of the button. Okay, and then I am giving a text to that. So the button name is button text is this button, hello world, and click me. This is the text I am giving, writing on the button object, and then I need to say when I click on it, what action to be taken. So that is what is the command. Okay, if somebody clicks it, or this is when clicking the quit, what happened, and then when I am clicking this window, this button, I am calling this command self say hi. Okay, this function method. So let me explain what I'm trying to tell you. If I click here, it is going to call this method, which is printing this message, which is coming here. Okay, but if I click quit, which is another button I have created with the text quit, it will call master destroy. So this whole thing will be destroyed. This object, the window, everything will be destroyed. So basically, we have created a small window with two buttons on it, and then we have explained what is the method to be called by. It's a dictionary. Okay, you can see the way it is initialized is a dictionary which is maintained. Command, you can give what method to be called whenever you click on the button. So this button is having a command saying that destroy the method, destroy the whole object or whole window. This says that say hi and then continue. Okay, now it is not that only class is there, you need to create an object of that type. So before that we need to create a root tk.tk root object, and then I am saying geometry 200 by 200. So this is the reason why it opened up here, or sorry, size of the window. Okay, 200 by 200 is the size of the window. If you see that it was a small a square, that is the size when it opens up, and then I am for the master root, this the root window, I am associating this object application object. Okay, so that is going to be opened on that window. So you are using the tk root as a frame on that you are, and then you are mentioning it on the screen where it should be, what size it should be, geometry of that window I open, frame I open, and then I associate an object here, which is a root object, a root frame, which is getting initially instantiated, and then I get into a main loop. So this will be continuously be running, waiting for your input on the um, application which is running. So when you say quit, that dies. Okay, that object exits and it dies. That's all. Okay, this is the a simple GUI application, and I'm saying that it has to be open in the top. That's why it opens it. You can play around with that. Okay, and then quit is in red color. A lot of things you can do. Okay, if you are very keen on playing around with that, you can do it. If it is first time you are hearing a GUI, but if you have already done it, this will be a child's play. Okay, so any questions on this? Okay, so I try to do something more. Okay, this is also a small window. Let me explain what I am doing here. I created some message box also. Okay, I'll explain you. Hello, show info, some callback functions. Okay, and what to callbacks, what to write it. Here I am writing something. Okay, and then I'm writing some text here. I think there are very standard things to do. So let me just show you. I am creating a tk frame, initial size of 400 by 400, which is this size. Okay, and then I create a label, welcome to Tinker, which is printed here. I really expanded it a little bit, so otherwise you wouldn't have seen it. And then I am telling the coordinate where it is supposed to be printed. So let me explain the coordinate. If you see here, x is 150, that is the top, as I mentioned, the top is origin. So x is little more, and then y is just 10. Okay, So where to start this particular text editing? Okay, so that's where it is. And then I am trying to put a button in the middle, so that is a relative position. You can say button place relative x and relative y. 0.5, when I say it is relatively at the middle, both are 0.5 each. Okay, you can give it in the floating point number. And then anchor, you can keep it here. Okay, so I created a button on this window. I printed a one text, welcome text there. Now when I create a button, I am also writing a lambda function. Okay, yeah, object, function object, which is setting a variable. Now what is this variable? It is a variable created in this frame. Okay, the top frame. It is not shown outside, but it maintains a variable in this frame, so it is associated with the frame. So that is a var. It is initially set to 0, and then whenever I click, this variable becomes 1. Okay, var set equal to 1. This is how you make it 1. Now what happens here? Now let me go further. Before that, let me show you. But when you click it, what happens? It is, this command is run, so you will have 1 coming there. It will be set to 1. Okay, now let me show you where is that I am exiting from there. Yeah, here. Okay, the code is here. Now button dot wait variable on var. Okay, now what I am doing is, on the button object, I am waiting for the variable to be set. Now when will this variable be set? It will be set when I click on the button, click me. So this sets it, and then it comes below. Okay, till then, now right now if I run it, it will print this waiting 1, and then it will be waiting here. That's what is happening here. It just printed the waiting 1, and then it is waiting on the button event. It's like an event on the variable which is to be set. So when will it be set? When this button is clicked and this command will be executed, which is nothing but this object, lambda, which anonymous object, which I, as initialized it. So it will set the variable to 1, and this will come out of the variable waiting. So it will come down and then create another canvas, which is another window. So let me just show you. When I do this, then it prints this, draws this image, and then waits again for some information, some event. So that's all. This is very trivial. Okay, let me show you what it is. Maybe I will keep both of them visible. Okay, so I create a canvas with a blue background, which is blue. Height is 500. This height and width is 500 each. So you can see that is a squarish. Okay, and then I create a line. 0 0 is 0 0 is this, and then 500 by 500 is in the end. So I'm drawing a line in yellow color, and then I can tell what is the width of my line to be. It is 3. This is the 3 pixels. Okay, that it's so small. Okay, you can decide what you want, and you are filling it up with yellow. So this line itself is filled with yellow color. Then another line I am this is what I am doing, canvas, and then create line. Then I am drawing a circle. Okay, can I do better than this? I have to close this window. I don't want to close it actually. Okay, I can't do better than this. Okay, you can see it. Sorry. Okay, so circle is again 100, 300. I think it's very trivial. I don't think I need to give you explanation. This is actually center points, and then this is, if I remember correctly, it should be. Do I have this coming up? I don't remember it. I think 50 is the diameter, and 3 is the thickness of whatever the circle to be drawn. And then what color you want to fill it up with. So you can see the brown color here, and then magenta, green, all that different objects I'm creating. And I am waiting for the click here. Again, like a command hello callback. So hello callback is a function which is going to be called, which prints continue or close the canvas, okay, to exit. So if I click here, this message will come, okay, message will come up. So you have to kill it forcefully. I don't have any other method to kill it. So main loop is keeping it, always engaged, continuously running. That's all. So I think this is enough. I'm sure you guys will are better GUI developer than me. Okay, I don't have anything on GUI. Anybody wants to ask anything, or it's okay? We can continue. Okay. Now let me close all the unwanted stuff. So GUI is done. Nothing much. And SQL is, that it's a very popular, database. It is integrated with the Python, SQLite 3, SQLite or SQLite, whatever you call it. There is a reduced version of SQL, and you don't need to install it. It comes from the version 2.5 onwards. What you want to do is, if you want to create a module, you need to have a connection object first, and then that represents the database, and then optionally you can create a cursor object which will allow you to run some SQL commands. Okay, SQL commands are create table, add entry, and then delete entry, or edit a line. It's like a tabular form, and you can do all the SQL operations on it. So that's all is the introduction, and not much to share. I am sure you are in the last class and you want to really do fast. So let me complete it fast, unless you have any doubts. Okay, what I am trying to do is I am creating a new new database, test new database, and creating a table. Okay, as I created a connection object, as I told you, and then if you want to execute any SQL command, like adding a key, and then what is the type of it, name, text, age is one entry, and whether it is what type of it is an integer or not, address is what length of characters, salary is in real. So you can, there is some type mentioned, and then the name of the entry in the table. So you can create a tabular column, okay, and enter different lines, values. So Mary with age, and then from which address, then what is the salary. So most probably these are all in dollars, not in rupees. So you can do this, okay, execute this command on this, then you can create a table. Okay, that you have created a SQL table, which is, as I mentioned it, it is in this directory where it is actually, it is in the current 17 class. So it is running on that particular directory, and this is the database. Okay, database file. A small data of this much size actually occupies 12 kilobyte. Okay, and if you try to open it in a text editor, I'm sorry, you cannot see anything. It's a binary file. Okay, this is what you will see if you try to open this database file. It's not a text file. So how do you read it? Now I have created a table, a new table. Okay, and then I want to read it. So now if I don't show you the code how to read it, then it's not fair. So I have written a code. Again, open this database as a connection object, then execute. I want a particular ID to be selected, and I want all the name and other things to be printed. And the cursor object gives you the option to execute command, and you can also, actually it's an iterator, you can iterate over every row. So it's well integrated. That's the beauty of SQLite 3, which is well integrated into Python. There you can read every row as an iterator, and then access it as a element and a row of 0, 1, 2, 3. Then you get all the elements to be printed. Okay, all the database that I created it, I'm able to print it here. Okay, so it's all class type. What you get is the each row is a class of tuple type. So once you get a row, the tuple elements, you can say array indexing is allowed in the tuple, so you can access the row. So that easy. Okay, you can create a database and access it so easily. Okay, it's very well integrated into Python. We can do it very easily, and That's all I wanted to show you here. Okay. Any questions? I think very straightforward. I don't think we'll. Sorry. Yeah, go ahead. I think so. I am not a database guy. Okay. Uh, I don't know SQLite allows or not. SQLite 3. Okay, one second. I am not a database expert, so I don't know. Yeah, SQLite database, how to store image. Yeah, you can store it. Okay, there are some means of doing it. If you want to use it, let me see. Insert image, because as I told you, it's a binary file, and you can store it as a byte array. Okay, because image is in the binary form, so he gives you a code to store an image, and then I am sure you will be able to get the image and store it, open the file, and all that you can do. Okay, it's a yeah. I think to answer your question, I did not do anything. I just googled it, so I think it is possible. Okay. Any questions? Any generic questions? Anything? Yeah, from anyone? Okay. So now next, what I wanted to show you. Let me remember. I forgot what was the plan. Okay, weak reference. Yes. So I don't know. Akash is there. He is the person who initiated this. Okay, great. Okay, so I am not going to explain you everything that but at least I'll give you an overview. Okay, so now the question that Akash wanted to know was what is the weak reference? Okay, actually this triggered me to explain about the garbage collector. Okay, um, which I did not mention at all. If you are from Java world, you may be knowing it, and as a Python guys, you should know this. See, what happens is whenever we are creating objects, what we do, we don't call new as in C++, we don't call malloc to create some arrays or anything. Just we want an object of any size, we just create an object, right? So each of those objects, maybe it will be internally objects, maybe having a bigger data structure, and they will have more memories. Now what happens is they're all in the object memory. Okay, there is a separate memory like a heap. Okay, like a heap, but um, we are not uh, given the opportunity or requirement that you need to allocate it and you need to free it. Okay, there is no requirement of malloc kind of thing. There is no requirement of freeing that memory ourselves. Now what happens, is this is like a ATM, which is like my son used to say when he was a child. Whenever he asks for a toy, if it is over budget, then we'll say that we don't have money. Then he will say that why don't you go to ATM and take money and buy me the toy. Okay, so now he doesn't do, but earlier he used to do that when he was 5 year old. So it's not ATM that it gives you all the memory that you want. Keep on creating the objects one after the other, or arrays of object, or open files. Remember everything that we do, and we do it in the Python world. So that means they have to be in the memory of the Python. Inside it should be allocated by the virtual machine, okay, VM. So this memory has to be given back to the system. Okay, how does the virtual machine itself gets the memory? It gets it from the OS. Okay, it maybe it will tell the OS to allocate a memory in the main memory, some block of area which will be used by the virtual machine. But OS also cannot keep on giving whatever the each of the instances of the virtual machine is asking for. So there is a limit on, though I told you that the memory management unit helps you to see that you have an infinite amount of memory. but it's only imagination. Okay, physically you are limited with whatever 4 GB or whatever you have on your machine. So the problem with this heap, the problem I'll tell you, it's not that you have a 4 GB limit that you want to release the memory back to the system. It is, you need to suppose if you imagine there is no garbage collector or nothing, you can keep on getting the memory that you want for creating all your objects, and your virtual machine is running forever. That means all the memory that you got are not going to be freed up. Okay, imagine it's not going to be freed up, it is going to be there, but whether you use it or not, it is going to be lying around. In that case, what will happen is you may run out of memory, but OS may say that, okay, I can give you memory, but you save this back, you allow me to save it into the hard disk. Then I will give you, maybe you are not using this much of memory that I gave you. I will put it into the hard disk, and then I will give you something else more, so that I get space in the main memory, because main memory space is limited and more processors are using it. So I need to now either discard your whatever I gave you, but I cannot discard it unless you tell me that I can discard it. So it will assume that OS will assume that it has to save the contents. Okay, whatever objects you have, O1, O2 objects are there, which you have stopped using it in your program. Initial stages you opened it and then you stopped using it later on. But these objects will be hanging around, and OS will think that you need it, and then it will be copying it into the hard disk and then keeping it. Maybe you may use it for later on. So this kind of problems will happen when you don't inform, or you don't even inform the Python. Then Python doesn't inform the OS. Then the memory keeps on bloating up, and some point it has to say that I don't have that space to, even swap area is full, hard disk is full, I can't give you memory. So it can come into get into that kind of a situation where memory is limited. So in that case, what you should do, you should do a garbage collection. Now why are we calling it as a garbage now? Because we objects whatever the Python program has used or created, okay, they are effectively in a identifier. It is all assigned to identifier. So anything you do, maybe object you created it, class C1 is a class. I created it with some number. This object is created, and this ID identifier or a label, okay, is pointing at this object, because it is a reference. What is being given back to the ID is reference. So this C1 is created, this object is created in the object memory. Now you use the ID whenever you want to use the C1. Maybe you want to call it, ID plus name, you want to call it, then you use this ID to refer to this. Now, what if somewhere down the line, I use the same ID label and then I create another object, maybe C2. This is a class C2. Now, what happened? After this point, this ID is going to point at this object, which is I have created it in here, and this identifier which was pointing at this is no longer now available. In that sense, the memory address of object C1, okay, or actually ID itself is an object of type C1. That object address is lost forever unless you have copied it, ID into something else, a new C1 some label. Then this new label is going to point to it, okay. But if you have not done this, you have effectively lost the address to this C1. Now what will happen? This fellow is a orphaned object, or the object which is not going to be referenced at all in the near future, not in the near future, forever. That object is lost, in the sense the address of that object is lost. I can't get it back. If you want to get it back, you will say C1 comma something. You are creating a new object now. You are not going to create the same object. If you call the same C1 comma 10, you are creating a new object. So this object is no longer accessible to the program. Now what do I do with this? Now I am not even asking the user, okay, if you are overwriting ID, make sure that ID free or free comma dot ID. There is nothing like this. Python has not given you even that control to you. The reason why they did not give it to you is, even Java, people make mistakes. The memory leaks are the most highly seen errors in C++ or C programs where you keep allocating but free, forget to free, or you free it with a wrong pointer and create a segmentation fault. So a lot of errors are there when users are given the opportunity or responsibility to free the object that they allocated. But here actually I allocated the object. C1 is not allocated by the language. I did it. Okay, I created the object, but I am not going to bother about releasing it back. Now, in that case, it is like this. Okay, if suppose in a traffic light junction, there are no policemen sitting here, what they do? Violators have to be caught. So they put a camera here, okay, a replacement, so that even violators can be caught. Now, the police is not there. That is, you are not asked to free the pointers anymore. Now, who will do it? So somebody has to do it. Then that the responsibility comes on the Python interpreter. Now, Python interpreter, if it has to do, it cannot arbitrarily free it. Okay, but you may say that no, I want to use it, and who asked you to free it? That's a problem. So what did the language do? They maintain some information. Now, whenever I say I create an object C1 and then something to some object C1, this is a ID label which is referring to the object C1. So it maintains, this object is created and it maintains a reference count. Now, what is reference count? It is not accessible to you. It is not a object attribute or a class attribute. It is the Python's own way of keeping track how many references are there in the program, which is currently pointing at the object which is created. And it also may remember when it was created and some sequence, okay, old object or new object, it knows. So now in case you know object C1, you have created it. Now you are assigning it to maybe another O1, another label O1. Then now it remembers that, okay, two references, O1 is also referring to this object. So reference count plus plus. So it is 2 now. Now suppose this function is gone, this O1 was label was not even visible here. It's a local variable, and it went out of the scope. Then it knows that O1 is no longer going to be able to refer to the same object. So it will say minus minus. So it will keep it 1. So as long as this label is visible and it is within the scope, and any program that is running in the future can access it using the label, this object, then it reference count will be non-zero. Now, when this label also goes out of scope or you overwrite it with some other object creation like what I did, then it becomes 0. The reference count of this object becomes 0. Now, once this becomes 0, what happens is there is a garbage collector, which is a background task, okay, background thread or task, maybe thread, okay, it's not a background task because VM itself is running as a process. So this must be a thread which will be running in the background, okay, apart from your program periodically, okay. So its job is to check whether how many objects in my pool are having a reference count which is 0, then release it back to the pool. That memory is released back. Now, no, anyway, it is not going to be used by the program and it's of no use for anyone. And I did not ask the user to release it, so I need to do it. That's what the Python takes the responsibility to release it back. So now what is the advantage? You will not go back to the OS to give me more memory because you have the internally whatever OS gave you earlier. Python has it, so it will reuse it for any more object creations that you have in your program. So that way we are saving something. At the same time, we are also losing some performance because whenever the garbage collector comes and runs, you are losing some useful cycles because it is going to occupy the CPU and it is going to run, which is a waste of, from our perspective, it is not directly related to application. As an application developer, we expect that we are given an infinite amount of memory, infinite amount of space in the CPU for running forever. Okay, that's our imagination. But the system is limited and it gives you limited energy, limited resources, including the memory and CPU. So now garbage collector is running. Now what is the weak reference? Now let us finally come to the weak reference. This is something which you can create it as a object, okay, and then make it to point to your object the same C1. Okay, imagine you know I am not showing you any direct implementation of it. You can always find out, but at least I want to explain you what it means actually. When you try to use it also, you will know the background what is weak reference. So weak reference is a kind of a reference. Any label in our case in Python is a reference. Okay, please remember, everything is a reference in our program. Now weak reference is one type of reference. Now what are the other references that we have? All the objects that we create and all the labels that we give, every object that we create, they are not weak references, they are strong references. And it actually makes the garbage collector to increment the reference count. Okay, please remember, they are all our own references or strong references, and we want to use them, and we don't want the garbage collector to release those memories without our knowledge. So they are called strong references. Whatever labels we have, they are all referring to finally an object in the memory, object memory, and each of them are referring to some same object, means it will be reference count will be incremented. So once the reference count becomes 0, okay, garbage collector takes some time to come up. Okay, it's periodic, I told you, and then even if it comes periodic, is not so greedy that all the objects in the world will be released. Okay, it is if you remember, there is a threshold is normally used. Okay, suppose this is the memory, okay, total memory available. Okay, not a main memory, I'm saying Python memory. Okay, let us call it as Python object memory. Now there is a threshold point, okay, somewhere. This is the total free. Okay, this is all free, if I call it as free, and this is used. Okay, now when it exceeds the limit threshold, then the garbage collector comes. Okay, imagine it comes, oh, it is exceeded, so it is going to release something. Okay, what is it going to release? It is something being used in this. Maybe you may have objects which are having reference count non-zero, maybe some may be 0, some objects may be having 0 reference count, but don't think that all the objects with the 0 reference count are removed. May not be, because it's not, normally it's called hysteresis. Okay, in the magnetic field, hysteresis, if you remember the BH curve, okay, I don't know how many of you remember, B is in the top, I think H is in the down. BH curve is a hysteresis. It goes like this and then falls like this. Okay, there is nothing in same place, it is falling. Okay, it is a hysteresis loop. Here also there is a threshold. Okay, when it crosses this threshold, garbage collector is forcibly made to run. Okay, because it is reaching a threshold. Okay, it is going to be dangerous if it allows to memory to be occupied, but it is not going to release everything. Even though, suppose imagine this much is still 0 references, it may only release this much. Okay, so that this can be still used, even if it is 0 count, it can be used. Now what I mean to say is, you can, suppose you are processing images, somebody asked me images. So if you are using images where you want to have a identifier, maybe face recognition or something, you are training a model, you will be using some, a lot of input images for training it. Now these images are open and it is all occupying the space. What will happen is, maybe down the line, after the training is done, you are going to optimize it. Okay, and then you may try to do a sample. Okay, as training with a simple set of some 10% or 20% of the same training data. You may be using it for verification purpose. Okay, after the optimization, in that case you need those images to be available for you to do a verification, but you are not you don't know, randomly sometimes we choose it. Okay, when we come here for the training time, we may randomly choose the input images to check whether our optimized image, or maybe you do a TensorFlow-Lite. Okay, from TensorFlow, if you want to convert it into TensorFlow-Lite, you might convert it using the converter, and then you have this model. Now you want to test it out whether this model is still accurate or not. So you need images for it. Which are the images? A subset of these images. Now these subsets may be lying out in the memory, which because you opened it for training purpose, but it may be released. Now this is the place where you can say that these images which I am releasing it, I want to keep it as weak reference. Okay. Now what is that weak reference means? I am saying I don't need these images anymore from my program. Okay. These images are there. Let me call it as image 1, image 2, but I am keeping a weak reference, let me call it as V1, W1, W2 a reference to these images. Okay, that means it's like this. I'll tell you one example. Suppose you want to go for a movie and then you bought a ticket, okay, 3 tickets, and now you are doubtful whether you are going to be going for the movie. So you give it to a friend. Okay, these are the 3 tickets. Movie is there tomorrow, 3 p.m. I don't know till now whether I am going to be going or not. Maybe by tomorrow 12 noon I will know whether I may need it or not. I may go it or not. So I may go for the movie. So friend will not like it if you ask for the ticket back. But if your friend is okay, if we are going to sell it in a black to make money, then it's okay. He can give you back. So what will happen is you may tell him that okay, I may ask you in case if you still not sold it to somebody or given to somebody friend, some other friend, or you are not thinking of going, I will take back the ticket and I will go for the movie. Otherwise you do whatever you want. So that is what we are telling the garbage collector. I don't need it now, but I don't know whether I may need it in the future or not. I have a weak references to those objects. In case if you don't release those objects in your periodic garbage collection, I will use it. Now the problem is your program may think that it is there or not. You may refer it. So if you actually have an image, okay, file and strong references if you have, and then by mistake it is deleted or garbage collector is removed by mistake, then if it is a strong reference, if you try to access the image and if it is not available, it is going to create an exception. Okay, because Python expects that to be there. By mistake, if something happened, then it's going to create an exception. But that is not the case with the weak references. Weak references, even if it is not there, it is not going to give you an exception. It will say none type. Okay. So what is the advantage? You can still recover from it. Okay. You can say my weak reference 1, I open it. Okay. I open the image or whatever. Okay. Then I check it. Okay. C, check it. C is equal to maybe none type. Okay. None type. Then what I will do? Okay, this object is removed. Maybe garbage collector came and removed it. So let me not use it now. Let me open it again from the directory. Okay, maybe you will access the file directory and open the file. So effectively, weak references helps you in terms of keeping a access to some object, at the same time allowing the garbage collector to freely release it, and you either if it is there you are lucky, you use it, otherwise you need to take care of it by again accessing the file or whatever and going forward with your training purpose, okay, or a verification purpose. So that's what is about weak reference. I think with this background, hopefully you will be able to use it